Here we have a circle, a tangent, and a chord. We have an angle between the tangent and the chord, and we can see it's 53.5 degrees. This angle standing here is also 53.5, and note that it's the angle standing on the arc which is cut off by the chord. If we move this point here, we know it will remain the same. This is the first theorem about the angle standing on an arc. The arc that the angle stands on is this one, cut off by the chord. Note that the angle stands in the segment opposite the minor segment cut off by the chord. This is why this is called the alternate segment theorem. If I move this point, note that both angles change, but they still remain equal. The angle here is equal to the angle here. Here we have a circle, a tangent, and a chord. The chord cuts off this minor segment just here. The angle here stands on the arc of the minor segment. The angle between the chord and the tangent is equal to the angle standing on the arc in the opposite segment. Because of this, we call this the alternate segment theorem. And if you use this, this is what you should write down. If we look at this carefully, we can see that for the same reason, C and D are also equal. So let's consider this one. We have this chord here, and A is here. A must be equal to 65 degrees by the alternate segment theorem. We can also see that we have an isosceles triangle. That means that this angle is 65 degrees. To find B, we could use the fact that the angles on a straight line always add to 180 degrees. So B is going to be 50 degrees, so that this is the case. So A is 65 degrees, which we found using the alternate segment theorem, and B would then be equal to 50 degrees, found using the isosceles triangle and the fact that angles on a straight line add to 180 degrees. Now consider this example. We have a circle, a tangent, and a chord, and we're trying to find the angle between the tangent and the chord. We know this angle is 120 degrees. If we add two lines to the diagram, and occasionally you may have to do this type of thing, then we can see that this angle stands on this arc, and this angle stands on the same arc at the center. It follows that this is 60 degrees. Once found, we can then use the alternate segment theorem. we can state, using the theorem, that A is equal to 60 degrees.